All right, we are going to, if I could get everyone's attention, and we're going to get started on example 3. We're going to call this one completing the square and the reason I call it an a value, that is a number in front of x squared, is because we're going to generally think of quadratic equations as something times x squared plus something times x plus a constant equals 0. All quadratic equations have this form. So now what's different about these examples is we have a number in front of x squared that we didn't have before. So we're still going to have the same steps that we had before. Step 1, get the x squared and the x by themselves. Step 2, complete the square. And step 3, squaring both sides. But we're going to add a preliminary step that we didn't have before. What's before 1? I guess this is step 0. Okay. We are going to either, in step 0, multiply or divide to get just x squared. So what do I have right now? In front of my x squared, I have a half. If I wanted to get rid of that half, what would I have to do to a half to get rid of it to make it 1? Times it by 2. So if we did that to part A, if I took everything, both sides of the equation, and timesed everything by 2, that would be like timesing 2 on one side of the equation and timesing 2 on the other side of the equation. That doesn't change what it's equal to, just changes what it looks like. So when I multiply everything by 2, do you see that I will get x squared plus 6x? What happens when I multiply the 9 over 2 by 2? Just get negative 9. And at this point, you would say to yourself, maybe I can factor, maybe I should complete the square. Okay? Now, because the question said by completing the square, you don't have to try factoring because they want us to complete the square. If we did try to factor this one, we would find out it doesn't work. It looks like it should because 3 times 3 is 9 and 3 plus 3 is 6, but it won't because you'd have to either have 2 positive 3's to get 6, but then you'd have a positive 9. Or you'd have to get, so there's no way to do that to get a negative 9. So we have to complete the square. Now we can go through our steps that we had before. I want to get my x squared and my 6x and leave a space, which means I'll add 9 to both sides, and then I'll leave a space. What number would be in there? Divide by 2 and square would be plus 9. So then I'd have to add 9 on this side. This half of 6 is positive 3. So this becomes x plus 3 squared. On this side I have 18. And now I have one thing squared. So I can square root both sides. I remember when I square root both sides, have plus or minus, subtract 3 on both sides, and I've solved for x. There's 2 answers here. It's negative 3 plus the square root of 18 is one answer, and negative 3 minus the square root of 18 is our second answer. I asked myself, can I simplify this further? Square root of 18 is 9 times 2, so yes, this is 3 root 2. And there's our final answer in simplest form. Question?
Did you get the plus 9 on each side?
So we take this number here. This is the one that's our hint, right? We think about the pattern when we squared a bunch of things between this and this. And to go from here to here, we divide by 2. 6 divided by 2 is 3. And then square. And that's how you would get 9. In our second example, We have a negative 5 out in front. If I wanted to get rid of that negative 5, would I multiply or would I divide? Or what? We could multiply by 1/5 or divide by 5, right? That would get rid of that. I think sometimes it's easier to imagine multiplying by, and again, you have to multiply both sides by the same thing. Of course, on the right-hand side here, that'll just be 0, right? But on the left-hand side, when I multiply by negative 5, that would go to each one of these things. And it would be the same as dividing. We just get an x squared. When I divide negative 10 by negative 5, I get plus 2x. And with my 2, when I divide that by negative 5, I'm going to get negative 2/5. So this one has a fraction. But we solve it the same way. Now that we've just got an x squared and a 2x, we get those by themselves on one side with a space. Add 2/5 to both sides. I don't know if it'll be, and a space. So what number goes in the blue space? Nope, not 4. It's going to be 1. Divide by 2, you get 1. 1 squared is 1. So I need to add 1 on this side as well. Here, this turns into a perfect square. It's x plus 1 squared. Here, in order to add those together, I'd need a common denominator. 1 is equal to 5 over 5. So 2 over 5 plus 5 over 5 would give us 7 over 5. We could now square root both sides. Remember the plus or minus. Now this whole side is getting square rooted, which technically means if I subtract 1 on both sides, that's the square root of 7 over the square root of 5. Is that in simplest form? No, because we're not allowed, in simplest form, we're not allowed the square root on the bottom. Okay? So we would need to multiply the bottom by square root of 5 and the top by the square root of 5. And we would get x equals negative 1 plus or minus the square root of 35 over 5. And I would accept that as a final answer. You'll most often see in textbooks, they'll say we would like your answer as a single fraction. So how do I add fractions together? I need a common denominator. Again, negative 1 is the same as negative 5 over 5. And that would give a common denominator. So another way that this could be written as one fraction all over 5 is negative 5 plus or minus the square root of 35 all over 5. Question. How did I get, you see how I got from here to here? So I made a common denominator and then I could add the tops, but the tops aren't like terms, so they still have to stay separate like that. And then it's all over 5. All right, so the questions you can do with values in front like this are 10 and 11.